This video is on solubility curves. What solubility curves do is they describe saturated solutions at various temperatures. If you look at the graph, on the x-axis you have temperature in degrees Celsius, and on the y you have grams of solute per 100 grams of water. The solubility of each substance, except for A, changes as you change temperature. If you don't understand what this means, make it very simple. Imagine you had a container, I'm on the lower left-hand side of the diagram now, with 100 grams of water, which is about 100 milliliters. They're the same, because the density of water is 1 gram per 1 milliliter. And let's say you started to drop substance C into this thing, into this beaker or test tube, whatever it is, okay? And you kept dropping it until you started to see that, and you kept stirring it, and you started to until it stopped dissolving, right? Well, how much of the mass would have dissolved in the water? That's solubility. So, and what you can see is it changed at a certain temperature. So let's say we're at 20 degrees Celsius, right? So solubility is the grams of solute, right, that can dissolve per 100 grams of H2O. But it's temperature dependent, okay? And what we can do is we can look at this graph and say, okay, let's say we're at 20 degrees Celsius. At 20 degrees Celsius, right, at 20 degrees Celsius, and we're looking at substance C right now. Make sure we're clear out we're talking about substance C. The amount of solute that can dissolve in 100 grams of water at that temperature is about maybe 21 or 22 grams. And again, you're estimating, so it's debatable. So this says the solubility is about 22 grams per 100 grams of H2O. Right? And that has a certain concentration, which can be given by the ratio, or when you divide through. 22 divided by 100 is 0.22. We'll come back to that number in a little while. Now, what that's doing is that's describing a saturated solution. You know that because there's this lump on the bottom, which means you added solute to there, and you got to the point where it would no longer dissolve. So a saturated solution has the maximum solute per solvent. And for substance C at 20 degrees, the maximum number of grams is 22 grams for every 100 grams of water. Now, let's say we did the same thing for a different substance, right? What would be a saturated solution of, let's say, substance B at, let's say, 80 degrees Celsius. Okay, so we go to substance B, we go out to 80 degrees, and we look and we make a big long dashy line here, right? And we get that about 10 grams of substance B can go into 100 grams of water. So that's equal to like 0.10. Now, two terms that are on this page are concentrated and dilute, okay? Both of these numbers I've got here are sort of a way of describing concentration because they're a ratio of solute to solvent. But then we can compare them and say which one is more concentrated and which one's more dilute. Now, basically, whichever one has more solute per solvent is more concentrated. So the bigger number is going to be more concentrated. So this one here is more concentrated. Sorry about that. And this one here is more dilute. Now those terms are relative terms. Notice something, both of these are saturated solutions, right? In both cases, we put a certain amount in there, we max it out, we have some of the solute on the bottom. These are both saturated solutions. So the terms saturated, unsaturated, and supersaturated cannot be used to determine whether something's concentrated or dilute. The term concentrated and dilute are relative terms. Right? Whichever one has more stuff dissolved in it is the more concentrated one, regardless of whether it's saturated or unsaturated or supersaturated. Now, what does it mean to be unsaturated? Well, let's go back to our first example, right? At 20 degrees Celsius, right, we're able to dissolve 22 grams of substance C in 100 grams of water. Well, what if we only dissolve 20 grams? This is analogous to if you're making a cup of tea and you just put a half a teaspoon in. If you do that, all of it's going to dissolve. Now, you know you could dissolve more sugar, right? So you're not adding the maximum amount of solute that could dissolve at that particular temperature. So also unsaturated means is less than maximum solute per solvent. Keep using per for the slash because it's a numerator over a denominator. Now, I don't feel like explaining how you can make a supersaturated solution right now, but I just think we should talk about and get the vocabulary word out of the way. If something is supersaturated, that means it has more than maximum solute to solvent. And that means that somehow we're actually above the lines on these graphs. Now, by the way, know something. Not everything changes the same way as you change temperature. So some substances increase in solubility as the temperature goes up. They tend to be ionic things. Some things tend to decrease in solubility as the temperature goes up, so less solute will dissolve, like substance B. They tend to be molecular substances. Very few stay flat like this. The weird exception to this, for some reason, is NaCl. It barely changes with a change in temperature, and I don't have a good reasoning for that. All right, right now I want us to be able to do one last thing, which is to look at three solutions and determine which is saturated, which is unsaturated, which is supersaturated, and also which is the most concentrated and which is the most dilute. And what I really want you to do is disconnect the terms concentrated and dilute with saturated, unsaturated, and supersaturated. Because just because something's saturated or supersaturated does not make it concentrated. In the example below, both solutions are saturated that we just did. Yet one is concentrated and one is dilute. Try not to connect these terms. Here we go. So I've set up a page with three solutions, each of which we're going to plot on the thing. So we're going to go from here and put a dot on the page for each of them, right? So first we're going to do this number one. We put a number one when we plot the dot. So for substance C, right, let's say we have 30 grams and 100 grams of water at 20 degrees Celsius. So here we go. 20 degrees Celsius. We go up to 30, which is right about here. Okay? And so we have 30 grams per 100 grams of water, which normally substance C could only hold about 21 or 22. That was like the example on the previous page, wasn't it? Right? That says something here. This solution has more than it should be able to hold, doesn't it? What that means is this solution that I just described is above the line. See, it's up above the line here. This is supersaturated. This is going to be unstable, but it can be made. We'll talk about how it's made tomorrow in class. Let's look at the next solution, solution A. Solution A, you can see the line is kind of flat here. We're going to go up to 60 degrees Celsius. So we always go to the temperature first. Then we go up to 35, which is right about here. And for solution A, it's a little bit, right, the line is right here. We're actually below the line. So we should be able to put almost 40 grams in there, but we have 35. That makes this solution unsaturated. The final solution, okay, is of substance B, and substance B at 80 degrees. So I'm going to go out to 80 degrees, right, and I'm going to go up to 10. Oh, wow, it's like right on the line, isn't it, right? So this is number 1 here, this is number 2, and this is number 3. Now, substance B is actually right on the line, which means this is a saturated solution. Now, just because it's saturated, or unsaturated, or supersaturated does not tell us which one's the most concentrated or the most dilute. The most concentrated has the most solute dissolved in it. Which one's the most concentrated? The one that's highest up on this graph. Number 2, this is our most concentrated one right here. It has more stuff in it per 100 grams of water than the other ones. And the weird thing is, the most concentrated solution we have here is the one that's unsaturated. Don't conflate two ideas. That means don't connect things that are not to be connected. Just because something unsaturated does not mean it can't be the most concentrated solution you have. The least concentrated solution, the most dilute one, is the one with the least amount of solute. This is the dilute one. These terms are relative terms. They're used for comparison. Now, sometimes I do buy things that are concentrated. For example, I buy concentrated sulfuric acid. But when I'm buying that, it's compared to other solutions of sulfuric acid that I might buy. And it's essentially the most concentrated solution of sulfuric acid that I can purchase. It's got the most sulfuric acid per volume, right? And it is concentrated, and that's because it has the most in there per volume. Okay, thank you. I hope that helps.